Hey, hey, hey! This is Big T with the Wolfman. Ow, ow, ow! Alright, calm down, Wolfie. We're coming at you retro style with a math video. Ow! No, seriously, it's just a math video. Calm down, man. Alright, so we're going to be focusing on graphing and equations and figuring out all that sort of stuff so we can get ready for a little SLOPE. And if you're following along with me, you know that is sloppy. Oh! Yeah, that's right. So I'm going to be teaching you a little bit about just graphing equations and figuring out equations from graphs so we can get ready for the sloppy. Well, in order to do so, I'm going to have to put on my teacher's voice. All right, I think we're ready. No, not that one. Let's go with... Okay, we're going to be starting graphing an equation. Yeah, I like that one. When we look at the equation, y equals x plus 3, to turn that into a graph, you can think about how we can make a function table, an xy function table, understanding that this is the x-axis, and along the vertical numbered intersections, we have the y-axis. So if x, let's just say, is 1, and we want our graph to be able to fit along this plane, then y would equal 1 plus 3, or 4. Likewise, if x is 2, then y is 5. If x is 3, y is 6. So, not a tough concept. You can go ahead and graph this by just plotting those points. 1, 4, 2, 5, 3, 6. You can see these are going to be linear graphs. And so we can just make an intersection and we have a line by following this through. And we'd probably want to use arrows at the end because this would extend on into space along this. And you can see every possible solution that would fit onto this grid would be the intersection of where this line is. So when x is 5, y is 8, and so on. And getting ready for slope, you can see the slope is going to be the angle of that line. And we will be talking about that more in future videos. So I don't think this is going to be a very tough concept, graphing an equation. We can practice one more right here. This one, sure, is probably a little bit more difficult. Graph the following equation, y equals 1/5 of x. So in this case, if x is going to be 1, then y is going to be 1/5 of that. 1/5. Downside with this is that's pretty difficult to plot that point on this graph. So I would start with saying if x is, let me use something smaller, if x is 5, y would be 1, because y is 1/5 of x. Likewise, so you want multiples of 5, because y is going to be 1/5 of whatever you do. So if y is going to be 10, then 1/5 of that would be 2, and so on, 15, 3. What's nice is all you need is 2 points to make a graph. So if x is 5, y is 1. If x is 10, y equals 2. We can't fit any more points on the graph, but we can see the solutions when we now use a straight edge to form a line. Your line is going to have to pass through both of these points. So you can see this slope compared to the last slope is at much less severe of an angle. So when we flip back to this, this had a greater slope when we look at that angle versus this is a little lessened. And you can see when 3 is, where 2 is, these are going to be fractions. They're not quite at 1. 6 is going to be a little over 1, but not at 2 when that's the x value. So all your solutions are along this line. Not a difficult concept once again. Where it gets a little more challenging is now when we work in reverse. Can you write an equation for this graph? You're not given the equation now. We need to come up with it. So let's use that same process and make our xy function table. When x is 1 on this graph, we can see the y value is 3. When x is 2, the y value is 6. When x is 3, the y value is 9. So from these points, we can now create an equation. And I'll show you the form that we need to write that equation in as well. Notice when we increase the x value by 1, the y value is increasing by 3. That's telling us it's in ratio. It's a 1 to 3 ratio, so the y value is being multiplied for each increase along the x value. By what is it being multiplied? By 3. So 1 times 3 is equal to 3. And as we increase by 1 each time, y is increasing by 3. 2 times 3 is equal to 6. So we can write the equation, and I'll write it right here at the top. Y is equal to whatever x is times 3. 1 times 3, 2 times 3, 3 times 3 is 9. So we would say either 3x, or you can write y equals x. But we do want to use this symbol, x times 3. The more sophisticated way to write it is y equals 3x. Let's do another one. And you can see they get a little more challenging. When you look at a graph like this, we are not moving in increments of 1 along the x-axis anymore. So that's going to pose a tougher problem. So we can just start with the 0. 0. And starting with the 0 is actually a very strategic move when we start doing a little bit tougher problems. When x is 0, the y value is negative 90. I don't know what the y value will be when x is 1 because we have increments of 10s along the x-axis. So I can see what y is when our x value is 10. When our x value is 10, y is now negative 80. When our x value is 20, y is negative 70. This is a little bit tougher problem to get an equation from it. First, let's just look at the relationship to see if there is a rate of change. Right now, I'll look along the x. When the x is increasing by 10, the y is, from negative 90 to negative 80, is increasing by 10. That tells me there is no rate of change. It is a 1-to-1 ratio. This is a difficult yet very important concept to start realizing that the x is not being multiplied, or to go from x to y, we're not multiplying by anything because they are in a 1-to-1 ratio versus in the previous problem, when x increased by 1, y increased by 3. So we knew there was something being multiplied. That's a tougher concept, and if you can think about it, even if you don't get it right now, that will be a benefit to you. So that means we're not multiplying by anything, and I could prove that. Because when I look at 0 to negative 90, I could think 0, well, there's nothing I could multiply 0 by to get to negative 90. If I started here, I could think, oh, 10 times negative 8, 10 times negative 8 would be equal to negative 80. But 20 times negative 8, well, 20 times negative 8 would be, well, not negative 70. Negative 70 would be just over negative 3 times, negative 3.5 times times 20. So we're not multiplying by anything here, and we could prove it that way. So let's look at a different relationship. To go from 0 to negative 90, well, that's simple. We are subtracting 90. It's just minus 90. Does that hold true for every other value in our function table? 10 minus 90 equals negative 80. 20 minus 90 equals negative 70. So if we are writing this in the form of an equation, we would write y equals whatever the x value is, subtract 90. Y equals x minus 90. For any value of x that you have, minus 90, you will be at the y value. Once again, I'm going to just actually do one more of these problems, and then I will show some practice problems that you can do. In this case, why don't we go ahead and start when the x is 0 again, because that's called the x, it's kind of our xy intercept. When x is 0, y is at negative 8. Once again, I could see now I'm not going to be multiplying anything here because I can't multiply 0 by anything to wind up at negative 8. But we can see if there's a constant change. When x is 1, y is negative 7. So when I increase by 1 here, my y is increasing by 1. So there's it's a 1-to-1 ratio, so nothing is being multiplied here. When x is 2, y is negative 6. So we're moving in a 1-to-1 ratio. 1 times negative 7 is negative 7, but 2 times negative 7 is negative 14, not negative 6. So our equation for this problem is y equals x minus 8. I'm going to go ahead and show 2 more problems. I want you to pause the video right now, and I want you to solve this equation on your own. When you've solved it, press play, and you can see what the solution is. I'm going to go through this right now. Hopefully you've solved the problem. I'm going to go write a table when x is 0, y is 0. We don't have much other information. It's hard to tell, so you have to look at areas of intercept. When x is 10 here, y is negative 60. So right now I don't know if there's a rate of change. But I do know when x is, the only other point I can get that's not on an intercept here that is clear is negative 10, positive 60. So let's see the ratio. When I increase by 10 here, I'm decreasing by 60. So right now we don't have a 1-to-1 ratio, which means we must be multiplying x by something. And it looks like it's a 10 to negative 60 ratio, which means it is also a 1 to negative 6 ratio. So we're going to be multiplying by negative 6 in this case. 10 times negative 6 is negative 60. Negative 10 times negative 6 is positive 60. And we're not going to be adding anything here because we can see our y is also 0. So our equation then is y equals negative 6x. Go ahead and try the next problem. Pause it. Okay, let's go ahead and solve it. Here, once again, we have a little bit of a problem. It's hard to find those relationships. So I could see here when x is 0, y is 0. The only other point that's really available to me is when our x is 8, the y value is 1. So I could see just by looking at this, when our x is increasing by 8, our y is increasing by 1. So it's an 8-to-1 ratio here, which means our y value is always 1/8 of our x. So to solve that, we can say y is whatever x is, and we could take